Now that we've learned how to display data graphically, we're going to take the next step, which is describing the distribution. So after you have come up with the appropriate display to show what the data looks like, you need to talk about what you see. And we use a 4-letter acronym to help you remember that, and it is SOCS, S-O-C-S. And that'll help you remember to identify the 4 points when describing a distribution. Now, the test questions in my test and on AP free response will just say, describe the distribution. They don't go into detail and say that you need to comment on the 4 things, but you do. You just have to know that that's what's expected of you. So the first S stands for shape. What is the shape of the data? And the shapes that we're going to focus on are symmetric, skewed, and that can be right or left, uniform, same amount, and bimodal. 2 modes, and we'll focus on that in the next slide. The O stands for outliers. Are there any outliers in the data? Those are numbers that don't fit. They're either really high or really low, and they don't fit kind of the overall averages. The C stands for center. What is the center of the graph? You will use numerical summaries for this, and it's either going to be the mean or the median. And we, again, will get into much more detail between those two. The last thing that you need to talk about, the final S, is the spread of the graph. And that's basically the range. Right? What values does the data set take on? So, and again, we'll get into more specifics on each one of these on each slide. Now, if we could talk about the shape, the main types of shapes. Now, so you can see what they look like. A symmetric graph is basically the same on the left as it is on the right. So to write this out in a full sentence, I would say the shape is symmetric. Now, because this is unimodal here, one mode, right? If you think about it, it's the same on the left as the same on the right. It's often, you guys know it as a bell curve. So I'm going to say that the shape is symmetric. Now, I'm also going to comment on the peak with a single peak at, in this case, it looks like a 4. Okay, so that's symmetric. Now, there are several types of symmetric graph. They don't have to be this nice bell curve, and we'll get into that. So the second one is going to be symmetric bimodal. Now, this graph's still symmetric. If I were to cut it in half, it's still the same on the left and the same on the right. But it takes on this bimodal look, this 2 modes, right? Mode, most. So you've got a bunch of 1s that are occurring here, and you got a lot of 7s. So we call this bimodal. So you would say the shape is symmetric and bimodal with peaks at 1 and 7. So there, I've talked about the shape and kind of talked about where those peaks are at. All right, the next one is symmetric but uniform. So again, these all are kind of the same on the left, same on the right. I'm just going to say here the shape is uniform. All right, you think about school uniforms, everybody looks the same. In this case, there's the same amount, roughly the same amount of all numbers. So that's what a uniform shape looks like. Now we talk about the 2 types of skewed data. We have skewed right. Okay, the shape is skewed right. with a peak at 2. All right, so that is skewed right. And then the last one, of course, we have is skewed left. Skewed left. So same idea, and I'm getting you used to writing in complete sentences, because when you answer these, you should write in complete sentences. So the shape is skewed left with a peak at looks like 6. Now, these two here, people get confused the most, the two, skewed left and skewed right. So the skew is the tail. Whichever way the tail goes, if you kind of look at this, you kind of think of this as like the tail. Whichever direction the tail goes, that's the skew. Now, when answering these, you will always talk about the shape. You say the shape is skewed left. You would say the shape of the graph in case, and apply the context of the problem. Okay, now let's talk about outliers. An outlier is an observation that lies outside the normal range of values. Again, there's two things you're looking at here. What does this look like graphically? Okay, so on a graph, it's very obvious sometimes, and sometimes you got to kind of make a guess, but that value there is outside of all the other data points. Here's most of the data, and then you got this guy out here, so that's an outsider. Okay, so often you can look at it and say a possible outlier. All right, then to get in more detail, you can use the 1.5 times outlier rule that we have. So 1.5 times IQR, rather, not outlier. So we have a mathematical rule to determine if something is an outlier. And it basically goes off the 5-number summary. So if you imagine, you got the min, you got Q1, you got the median, you got Q3, you got the max. And you would do a box plot. Okay? If this was, again, perfectly symmetric. Now, to determine if something is an outlier, basically you're going to use this 1.5 times IQR rule. Now, the first thing you need to know is the IQR is the box, basically. The IQR is Q3 minus Q1. All right, then, that's going to give you a single number. And basically, you're going to add that number to the third quartile, and that's going to give you the upper cutoff. So that's going to be Q3 plus 1.5 times IQR. And that's going to give you the upper cutoff. All right. And then you take that same 1.5 times IQR number that you had here, and you're going to subtract that from Q1. So Q1 minus 1.5 times IQR. And that's going to give you your lower cutoff. Again, we'll get into more detail, more practice with these, but for right now, that gives you an idea of what it's like to be an outlier. Okay, the next, center. We're going to use mean or median. Now, both pretty easily, both easily calculated. But when to use what is kind of the question that comes up. So, if you've got symmetric data, what happens is the mean is in the middle, 50% on the left, 50% on the right. And the median is 50% on the left, 50% on the right, and the mean is the average. Now, in a symmetric data, those happen to be the same. The mean equals the median. Okay? Now, the other two types of data you have are skewed right and skewed left. Now, in this case, the mean always gets pulled towards the tail. And the median remains in the middle. Okay, so in this case, the median is less than the mean, and in this case, the median is greater than the mean. And that's, again, another concept that will come up a lot. So if the data is skewed, you're going to use the median as a measure of center. And if the data is symmetric, you're going to use the mean as your measure of center. Okay, and finally, we have the spread of the graph. Now, there's several ways to report back the spread. You can say the spread. Let's say that I had numbers that ranged from 5 to 37. There's a bunch of numbers in there. If I was reporting back the spread, I could say the spread is from 5 to 37. That gives me the min and the max, basically. Now, this other thing I talked about is called the range. The range is, and this is a common error, if I take 37 minus 5, the high minus the low, I get 32. The range is 32. It's a single number. So the range is a single number. The spread is the low to the high. And that's a common mistake. So you don't want to say that the range is from 5 to 37. The range is this single number when you subtract the high from the low. Okay, a couple of other ones. We've got the IQR is a measure of spread, and it again is Q3 minus Q1. And then we have the standard deviation. Now, this is a new term to us, and we won't get into a lot of detail in this video, but it is coming. Standard deviation. Now, the IQR you're going to pair with the median. All right, because when we calculated the median, we calculated the quartiles and kind of the 5-number summary. So the IQR is always paired with the median, and the standard deviation is always paired with the mean. Okay, so that's a pretty good start. It's an overall kind of review of the 4 things that you need to identify when describing the distribution.